Okay, a very good evening everyone and welcome to the chemistry class. So after a very long time, finally we have the chemistry again and I hope this is the second class, right? Okay. So Kohima Center, are you there? Just write it down, okay, so that I get to know that you people are there. And I think in the last class your camera was also working. So if you can share your camera port number, that would be great. And in the chemistry, we have started from the mole concept, the very first chapter, you know it better. And I think we have discussed that how to relate the moles and how to, convert the mass into the moles, or if any number of molecules is given to you, then how to find out the moles from them as well. Right? Kohima Center, are you there? Just write it down, na? This is the screen present over there. Just write down so that I get to know that you people are there. I'm going to write the few topics which we have covered in the last class, okay? And I have seen that some of the students had sent the answer in the WhatsApp group also. And that was great, very nice, okay? Now I'm going to write here. Just a second. Yes. So we have started with the mole concept. Right? Kohima Center, if you are there, please write it down, okay? I'm just going to write the few things which we have discussed till far. So we have discussed the in the starting we have talked about the that you should at least remember the 20 atomic numbers, okay? It's very, very important to learn what is the atomic number. So we have discussed the atomic numbers. We have discussed the atomic mass unit, AMU, I'm writing. We have discussed the moles, and the two formulas were there of the moles. I'm going to write those two formulas if you people remember it. The mole is equal when a mass of any particular, any element is given. So, okay. Yes, Kohima Center is being connected over there. Satna Center is also there. Do we have any student from Satna Center in the 11th class? Okay, yours is the first class? Okay. How many students are there, Satna Center? Only one student is there, okay. Do you want to share, can you share your name with me? What's your name? Because it's difficult to ask the name when we have a huge class, of the 40, 50 kids. But you are single, na? So that is why I'm asking. Write down your name. So if this is your first, Jia, okay. Jia Ramchandani, okay. So Jia, we are, Tetso College is also there. That is nice, okay. So we have started with the mole concept in the chemistry in the 11th. You know that this is the very first chapter, right? So I hope you have, Jia, started the mole concept in your school. I think you have started the mole at least in your school, and Tetso College also, okay. So if you find any kind of difficulty, any doubt would be there, you people feel free to write. So you can write it down. So in the mole, it's like the given mass by the molar mass. We have one more formula. I'm writing here the formula. We'll do some of the questions also. So mole is any number of particles the number of particles divided by the Avogadro's number. Okay? So you people remember the masses, the atomic mass and the atomic numbers. It's very, very important, okay? It's very, very important. Let's do some question. I'm giving you one question, okay? So you can better relate it. So find out the mass of 1000 grams of CaCO3. Sorry, mass is already given, moles. You have to find out the moles. Just try. And you people know that the mass of calcium is actually the 40 grams, carbon is 12 grams, and oxygen is 16 grams, okay? Although I am giving you this data, but these things you should know, okay? At least 1 to 20, na? 1 to 20 atomic numbers should be known to you, atomic masses should be known to you, right? Just try this question. Tetso College, you people were there in the last class? After a very long time we are having the class. Now I didn't remember that you were there or not. Tetso College students. Yes, very good, Satna Center. The answer is correct. So this is yours first class also, right? Tetso College. Okay, so let me know if you have any doubt, okay? Okay, this is your first class. No problem. No problem, Tetsu College. So Kohima Center is there. Kohima Center, your camera is working? Kohima Center, if your camera is working, let me know your camera port, okay? Now those who don't know, look at the screen how to solve this question. First of all, you have to find moles and the mass is given. So obviously you people will be applying this formula, right? So you know that moles will be equal to what is the given mass? Given mass is the mass which is given in the question. That is the 1000 grams. This is already given. Now what is the molar mass? Molar mass of CaCO3 you have to find out. How you will find? Now you are able to see there is one calcium. So 40. I have given this now. 40 is the molar mass of the calcium. Plus carbon will be 12. Now how many oxygen are there? For one oxygen the mass is 16, right? 3 oxygen are there. 3 into 16 it will be 48. 40 plus 12 plus this is 48. It will be 100. Okay? And when you try more and more type of questions, you will get to know that like some of the masses are always there in my mind. When I talk about NaOH, it's 40 grams, CaCO3 100 grams, H2SO4 98 grams. These are already in my mind, okay? So when you people will do, you will also get to know about them. So what is the answer coming out? 10 moles. Any doubt, anyone? Because some of the centers are having the first class today, na, that is why I am going slow by slow, okay? Little bit slowly. Tetsu College, you got it? Okay, no doubt to Satna Center, and I hope there is no doubt to Kohima also. Tetsu College, keep on writing, okay? Feel free to write anything here. Obviously related to the chemistry. Nice. Okay, let's do one more question then. How many molecules are present in? How many molecules are present in 0.5 moles of water? Do it. Quickly do it, tell me the answer. What will be the answer, everyone? Write down the answer. 0.5 moles is given to you. This time the number of particles you have to find out, right? Apply the same formula. Not obviously the same formula, the two were there, na? So just apply the formula for the number of the molecules. This one. 9. How you are getting 9 molecules? Look at the screen, Tetsu College. I am writing that second formula, na? Moles is equals to number of particles. So this time the particles are the molecules divided by Avogadro's number. This is 6.022 into 10 to the power 23. This is the number, right? Look at the screen. Na is the Avogadro's number. Na is Avogadro's number. It's 6.022. This is merely a number. What is happening now, Tetsu College? Like if I say na that I have this water bottle with me. If I say that I have 1 mole bottles with me, okay, it means I have 6.022 into 10 to the power 23 bottles with me. If I am saying I have, this marker is there, I have 5 moles of markers with me. So it means I have 5 into 6.022 into 10 to the power 23 markers with me. It's just a number. So to say this number is such a big thing. Now I am again and again saying. So we have given a small term to it, which is a mole. You are getting me? So it's just a number, right? So the value of the number is given over here. Now the mole will be equal to number of molecules by that Avogadro's number. So what we will do? Like I can say that we can go by the unitary method as well. That 1 mole of water molecules contains, like 1 mole of water is what? Avogadro's number, 6.022 into 10 to the power 23. So this is the number of molecules for 1 mole, right? So how many molecules will be there in the 0.5? It means half of them are there. So what will be the answer this time? That it will be getting by half. So divided by half, okay? So same you will be getting with the help of the formula also. That number of molecule by 6.022 into 10 to the power 23. So the answer will be obviously for number of molecules the answer will be, it would be 3.0 as the people are saying, 11 into 10 to the power 23. Getting it? Tetsu College okay now? I have just put it into the formula, right? And you can look for the video because you people have missed the last class, na? So what you can do, I'll share the video to your group, right? So you can just go through the video, all of the concepts will get clear. Because I have discussed all these things in the last class. Right? Okay, now let's talk about something new, that question which are given in the homework also. First of all, give me the answer for this one. If I have 1, it's not a question, simply we are just talking about the term. 1 molecule of H2SO4 you have. How many atoms are there? Tell me. I have a single molecule, let's say, of the H2SO4 with me. How many atoms will be there? Satna Center is there, Kohima is there, and Tetsu College. Nice. Tell me now, it's so simple, why you are taking so long time? A simple 1 molecule of H2SO4 I have. How many atoms are there in H2SO4? Jia, tell me what will be the answer. Kohima Center. Kohima, what is your camera port number? Write it down, na. Last time the camera was working. Kohima Center, I haven't given you 1 mole. I have already given you 1 molecule. Think about it. A single, listen to me everyone, a very single 1 molecule of H2SO4 I have. Look at the screen. This is single H2SO4, right? This is a very single molecule. Now, how many hydrogen atoms are there? How many hydrogen atoms are there? 2 hydrogen atoms are there, 1 sulfur is there, and 4 oxygen are there. So, what are the total number of atoms? 7 atoms. Very good. Obviously, Satna Center is correct. So, 7 atoms, na Kohima. I am talking about a one single molecule. What you are saying, na, let me write like this. So, I can say that 1 molecule of H2SO4 has 7 atoms. Let's say if I am giving you 10 molecules, that what will be the answer for the 10 molecules? So what will you say? If one is having the 7, the 10 will be having the 70 atoms, right? What will be the answer for 1000 molecules? So you will be saying, ma'am, it would be 7000 atoms, right? What will you say if I write that I have Na molecules? Na means Avogadro's number. So what will you say? That 7 Na will be the atoms, okay? So Na molecules means what? I am talking about the 1 mole. That 1 mole H2SO4 will have 7 Na atoms. You are getting it? Everybody understood the thing which I am telling right now? Tell me, Kohima, any doubt? Jia, you have any doubt? Tetso College, any doubt? Okay, so everybody understood this? Very nice. Tetso College, I hope you people are getting it. If any doubt is there, let me know, right? So, let's do one question then. How many atoms are present in 5 moles of water? First of all, you people will find out the molecules. Tell me, I'm waiting. Okay, just go step by step, right? First of all, find out the number of molecules here. 15. How you are getting 15, Kohima Center? Okay, just find out the number of molecules, everyone. 5 moles is there, find out the number of molecules. 1 mole has Avogadro's number of molecules. So 5 mole will be having how much molecules? Find out. Everyone look at the screen, I am solving it. This is given to you. What can I write? Can I write it like this, that 1 mole of H2O it means 6.022 into 10 to the power 23 molecules or Na molecules. Here what I can write it, look at the screen. 5 moles of H2O will be having, if one is having Avogadro's number, so 5 will be having 5 into 6.022 into 10 to the power 23, or can I write it like 5 Na molecules? Clear? Both are the same thing. So I also know that one molecule, one H2O molecule, H2O, is having 3 atoms in total. A single one molecule contains 3 atoms in total. So I have calculated the number of molecules from the 5 mole, na? So can I write it like now 5 Na molecules will be creating what? 5 Na into 3. That would be 15 Na molecules, atoms. Yes, now the answer is correct. So you people can, just check it. 6.022 is there, 10 to the power 23. So you can just check it, you will get to know. 19 to 10 to the power, 23. Got the concept? Tetsu College, I hope you are getting it. Tetsu College? Got the concept right? Tetsu College, if there is any doubt, please let me know. Okay, so you have done it. Good. So number of atoms we are now able to calculate from the number of moles. Let's do one more question. I am taking you into a little bit detail. Find out the total molecules. I think this type of question I have given in the homework also. And total number of atoms try this in 500 grams of CaCO3. A very similar kind of question, the first question which we have done in the today's class, I told you to find out the moles there, okay? So you have to apply the same approach. First of all, you people will be finding the number of moles, then you will find the number of molecules, and from the molecules you will find the number of atoms. Do it quickly. What will be the answer? Write down the answer, everyone. Okay, I got the answer from Kohima Center. Kohima, today your camera is not working. Kohima Center? Jia, you got the answer? See, I am doing it. See, look at the screen. We have, that is why today the camera is not functioning. It's okay, no worries. So 500 grams of CaCO3 is there. So I am saying that first of all, let's find out the moles. So moles will be like 500 given mass by molar mass. So given mass by molar mass. So that will be 100. Okay. So this is the 5 are the moles now. Okay, we got the moles. 5 are the moles now. So we have to find out the total number of molecules, right? I know that 1 mole contains 6.022 into 10 to the power 23 molecules. So 1 mole contains this much amount of the molecules. So 5 moles. Now we have done from mass to the moles. We converted the mass to the moles. 5 moles will contain 6.022 into 10 to the power 23 into 5 molecules. Or if you want, I can write it like as 5 Na molecules, right? So these are the molecules. I know that 1 molecule like CaCO3 now contains how many atoms? Count down the atoms, na? So 3, 4, 5 contains 5 atoms. So 5 Na molecules. They will contain simply unitary method. 25 Na I am getting. Okay? Just check if you people are getting it or not. Now you can simply find it out. If you want, you can do the complete calculation. So you'll get the answer. 150. We are getting 150 into 10 to the power 23. Clear, everyone? I hope this is clear, right? Satna Center, this is clear to you? Any doubt you have? Okay, so we are done with the mole part. The how to convert the moles, the atoms and the molecules. This is clear to everyone. Now let's do one interesting topic, and you people will tell me if you have done it. Limiting reagent. You people have done limiting reagent? No, you haven't done limiting reagent? Okay, let us do it. It's, it's a kind of, in the short form, we used to call it as LR also, okay? So we will be finding an LR. But before finding the LR, we should do some basic thing. Wait. Don't write limiting reagent now. We'll do some basic things. Like, everyone look at the screen. I'm telling you how to deal with the reactions here, okay? Let's say, I have a reaction like this. I have a KClO3. If I heat it, I get, let's say, KCl, and if, let's say, I get KClO. Okay? And if you want, you can balance it. So you will be balancing it like this. So you will be getting, instead of KClO, just wait, let's take the simpler example. I'm just trying to make it simple. CaCO3, let's talk about the carbonate. We all know this. You people have seen this reaction before, right? Calcium carbonate is there, CaO is there, and CO2 is there, okay? Now what happened, many times in the question they will give you that, let's say, 5 moles of CaCO3 is being burnt. Tell me, I'm writing the question also. Everyone just write it down. 5 moles of, I have written the equation, 5 moles of calcium carbonate is decomposed. Decomposed means you are heating it. Decomposed, then find out the moles of CO2. Any idea, anyone, how to do that? Any idea, anyone? Let's say 5 moles of CaCO3 is given and they are saying it will decompose and find out the moles of the CO2. Let me tell you, okay, how to solve it. Now, whenever any equation kind of thing is given to you, the very first step is, right, I'm writing the solution in the steps. The very first step is write the equation. Write the equation, okay. Many times in the equation, they itself give you the equation. If not given, you have to make the equation, okay. So, let's say if I am writing it, it would be like this, okay. So, they will give you the things many times. Now, what happened in the, because obviously it is so difficult to remember all of the equations. So, they will give you that this is the reactant. When you decompose it or heat it, you will be getting this as the product. So, you have to just write it down in the form of the equation with the help of the formulas, right. So, this you have done. Now, the second step is balance the equation. Balance the equation. You people have studied the balancing in the junior classes. Everybody knows the balancing. Write it down. Okay. And are you able to see that this equation is already balanced? This equation is already balanced. So, I will be writing it again in the same way. Okay. Because this is already balanced. Now, what happened? Let's say in the balancing, you know that you apply some factors over there, like 2 apply, 1 apply, 3 apply, something kind of this. Obviously, this is the balance one. Why would I apply over here? But I am simply saying, let's say I can say that 1 is there, present over there. Understood? Now, first of all, the numbers which you apply while the balancing, this is known as stoichiometric coefficient. These numbers are known as stoichiometric coefficients. I'm just telling you the terms, the technical terms, okay. So, whatever the equation is given, when you balance it, you will be getting certain numbers ahead. Those numbers are known as stoichiometric coefficient, okay. Now, what you will be doing now, you have to judge the equation with the help of this stoichiometric coefficient only. Now, what does this stoichiometric coefficient means? It means that, can I write it, because I'm getting 1 over here now, so I will be saying it like 1 mole of CaCO3 gives 1 mole of CaO and 1 mole of CO2. You understood it? If let's say I am getting any 2 or 3 there now, so I will be writing that 1 mole is giving me 2 moles of this or 3 moles of that, okay. Tell me everyone, this red line is clear, because this is very important. Because if you first get to know about the stoichiometry, this is which you will get after the balancing, right? Everybody understood this? Write it down. And Tetsu College, this is the new thing for you people also, okay? So that is great, that nothing is related with the previous topic, okay? So this is understood by everyone. So now what is given in the question? I was given with the 5 moles. I already know my equation for 1 mole, okay? So what was asked in the question, that for the 5 moles, how many amount of CO2 is produced? So I already know that with this equation, I know that 1 mole CaCO3 is giving me 1 mole CO2. So what can I say about the 5 mole CaCO3? It will give me 5 moles of CO2. Clear? Take your time and tell me if it is clear. Clear now? Okay. Okay, now you people try one question. How many mass? What will be, you will be telling me this one. What will be the mass of CO2 when 10 moles of CaCO3 is decomposed? Tell me. Perform the same steps, write down the equation, then try. Try this, you have to tell me the mass here. Meanwhile, I'll search for the next question, okay? Oh, I got the answer from two centers. Tetso College, where are you? Same thing, CaCO3 is there. You will again write the equation. You will say that, ma'am, it is balanced. So 1 mole of CaCO3 is giving 1 mole of CO2. So 1 mole CaCO3, I'm writing it simply, is giving me 1 mole CO2. So how many moles are given to me? 10 moles. And see, I'm directly giving you the moles here. Many times in the question, I'll give you the mass. That, let's say, I'm giving you that 1000 grams of CaCO3 is decomposed. So from that mass, first of all, you will find out the moles. You know everything in the moles. You know that this stoichiometry deal in the terms of the moles only, okay? So if the mass is given, you will convert it into the moles, right? So like here, you will be getting 10 again. So 10 moles of CaCO3 will be giving you 10 moles of CO2, right? And I have asked about the mass. So you apply the formula moles equals to the given mass divided by molar mass, which is 44. So your answer comes out to be 440 grams. Clear? This is correct. Tetso College, you got it right. The other students, do one more question. This is the equation given to you. KCl you are getting plus O2. This is the equation given to you. Just a second. Meanwhile, you can try and you can balance it. I'm just trying to, change the values in order to make your calculation easier. So right now I don't have the values, so I'm giving you the direct one. Find out Okay, find out the moles. Let's make it easier. Find out the moles of oxygen. If 10 moles of KClO3 is present. Try it, everyone. I tried to make it simpler one, you know. First of all, you have to balance the equation. You got the answer? Yes, very good, Satna Center. The answer is correct. Kohima Center, try for it. Very good. 15 is the answer, right? So you people got the balancing, na? So I'm writing it again here, you know. So it would be like KClO3. You are heating it, you are getting KCl, you are getting O2. So if I apply 2 here, I will be writing 2 here and 3 will be here. So 6 oxygen are balanced, okay? So you have to do the balancing first. You cannot solve it directly, your answer will be wrong. Now I need to find out the moles of O2, right? So from this stoichiometry, what I am able to see, that 2 moles of KClO3 is giving me 3 moles of O2, right? 2 moles of KClO3 is giving me 3 moles of O2. So 10 moles of KClO3 will give you how many moles? Okay, so that will be like 1 mole will give you a complete unitary method. You have studied in your junior classes, na? It will be 3 by 2. Here it will be 3 by 2 into 10. So your answer will comes out to be 15 moles. Clear, everyone? Easy, na? So if any question is given to you, you will balance it and then you will check for the stoichiometry. Right? Is it easy or tough? This stoichiometry part. Kohima Center, let me know. I remember that is the all boys center, na? And now I have the all girls center also, although the only one single girl is there. Okay, good. Kohima Center, so any girl in your center now? Or still it's a all boys center? Tell me. Still it's all boys center? Oh, all boys. Okay, no problem. Okay. Now let me tell you one interesting thing. Now let's talk about the LR concept here. See everyone, let's say now I have N2, I have H2, and I have ammonia. If you can relate it, everywhere where I was talking about only the stoichiometry part, I was taking one reactant only, right? So obviously it would be easy to deal with the stoichiometry with the help of one reactant. Now I have taken the case of two reactants. First of all, you people will tell me the balanced equation. What will be the balanced equation? See, let me do it. You will be getting a balanced equation here like this. I'm writing a balanced equation. N2 plus 3H2, you will be getting 2 moles of NH3. Now the equation is balanced. I hope everyone understood the balancing part, right? Now how can I deal it? Obviously I would be saying it as that 1 mole of N2 combined with 3 mole of H2 gives 2 moles of NH3, right? So this is absolutely correct, that after the balancing you can say it like that 1 mole of N2 combines with 3 mole of H2 and I'm getting the 2 moles of ammonia. But where will the problem lie? The problem will lie here when it is given, when this will given to me, Look at the screen. Let's say in the question it is given that the 4 moles of N2 is present. The 4 moles of N2 is present, okay? And let's say we'll call it as 15 moles of hydrogen is present, okay? Obviously this time if I'm taking the two reactants, so it should be, it should give me the amount of both of the reactants, right? So both of the reactant amount is present, and now they are asking me that how many moles of ammonia has been formed, okay? Now in these cases, you look at the screen everyone, you cannot directly say that 1 mole is giving me the 2 moles, that 1 is giving me 2, so 4 will give me the 8. And look at here, if I go by this one, 3 is giving me 2, so 15 will give me what amount? So everywhere the answer is varying. So you have to check first of all that which particular reactant you will be taking into the consideration for getting your answer. Now, how we will get to know? We will get to know with the help of the LR. Now listen to me everyone very carefully. Let's take an example. Let's say these days in the Delhi it was very, very hot. So we were in the habit of drinking the lemonade. Obviously it's good in the summers, in the hotter, and when the hotter is the temperature. Let's say I'm making a lemonade. You people all, Kohima Center and Satna College and Tetso College is coming to the Delhi in summers and very hot is the region, and I am making lemonade for you all, okay? A welcome drink I am going to give you. So I am making the lemonade. Everybody knows the recipe of the lemonade, right? So you are taking the water, you are adding the sugar, you are adding the lemon also, and the salt, whatever suits your taste, okay? So, now listen to me. In order to make a good lemonade, I need all the things accordingly, right? I need the lemon also, I need the sugar also, I need the salt also, right? Now I am saying that, if I, let's say, keep on adding the sugar again and again, if I am adding the sugar, my sugar is in lot of quantity, but the lemon is in very small quantity. Will you be able to say that ma'am, you have made a very good lemonade? Obviously not. You will say, ma'am, you are giving us just the sugar water, there is no lemon into it. You are getting me? So I am just saying that every component should be in the appropriate amount in order to get a good solution, okay? Now look at the system of this ammonia. The reaction is there in front of you. Now what is happening? Let's say I have a beaker, I have a big beaker with me. I put a N2 into it, I put a nitrogen gas into it, I put, the hydrogen into it. What will happen? They will mix and I will be getting the ammonia, right? So what is happening? Now for making the ammonia, what is the required quantity? I need 1 mole of N2, right? And I need 3 moles of hydrogen. When they will mix, I will be getting 2 moles of ammonia, right? This is exactly what we get after the balancing. Now listen to me very carefully everyone. Let's say I have the same beaker. I was making the ammonia. So I was putting the nitrogen, I was putting the hydrogen. Let's say I keep on adding the hydrogen only, but I am not adding the nitrogen. Will I be able to get the ammonia? Obviously not, right? So I am saying that if I keep one thing in very large quantity, I will not be able to get the desired product, okay? So anything which is in the smaller quantity, right, that will decide that how much product will be formed. Now let's take an example again. I have the container, I have the nitrogen, I have the hydrogen. The same example I am taking. What I am saying that I am putting, let's say I am keep on adding the hydrogen only, but my limited amount is of the nitrogen. So how much ammonia will get formed, this will be decided by what? Hydrogen or nitrogen? You people will tell me. I hope you people are getting the concept, right? I am explaining again. I am asking you the question that let's say I want to prepare NH3 at my home, I am putting nitrogen, I am putting the hydrogen, but I am keep on adding the hydrogen. Hydrogen is in excess quantity. Now you will tell me what factor will decide that how much ammonia will be formed? Nitrogen or hydrogen? Yes. I got the answer from Kohima and Satna Center. Exactly. Nitrogen will decide now because this is I am having in a smaller quantity. So if let's say all of the nitrogen is reacted and you keep on adding the hydrogen, so just keep on adding, what will happen? Nothing will happen. You will not be going to get any ammonia there, right? So anything which is in the smaller quantity, which is lesser in the quantity, limited, that will decide that how much ammonia will get formed. Why I have given all these things, these examples, because when you check here now, the reagent which is in the smaller quantity, from that particular reagent you will be matching the stoichiometry, okay? Now look at the screen. Look at the screen, everyone. Now this is given, this is the question. You have to find the amount of NH3. This will be given in the question, right? Now I know that I have balanced the equation and I know that 1 mole of N2 react with 3 mole of H2. First of all, let's deal with only N2 and H2. We are not taking NH3 right now. I am not writing NH3, okay? Because first of all, we have to decide that because 4 mole and 15 moles are given, this is the given quantity. These are the standard which you get after balancing. This is the standard, okay? But this is the given which will be given in the question. So according to the given quantity, first of all, you have to check that which one is your LR, which one is the limiting reagent, right? Now 1 mole of N2, this is the standard, right? That 1 mole N2 reacts with 3 moles of hydrogen. Now let's check for this one. Now what is given in the question? That 4 mole of N2. Now just keep this fixed. This is given, I am keeping it fixed. 1 mole N2 requires 3 mole of hydrogen by standard. So let's check by standard now that 4 mole of N2 will react with how many moles of H2? You people will tell me. Ideally, how much is required? That 1 mole of N2 if reacting with 3 moles of H2. So 4 mole of N2 is ideally requiring how many moles of H2? Tell me. Exactly. Kohima Center, what is your answer? Tetso College. 12. Exactly. Ideally, I require 12 moles of H2. But how many I have? What is given in the question? I have 15. Now you tell me, do I have it in excess amount or in the limited amount? Tell me. I have it in the excess amount or in the limited amount I am having? Ideally, I require 12 only, okay? But what is given to me? 15 are given to me. So I have the excess amount, exactly. So what is my excessive reagent? So the excess reagent is H2. Now what is my limiting reagent? It means when I put the 4 moles of the N2, it will take only the 12 moles, okay? And the rest left amount will be the 3 moles, right? So limiting reagent will be the N2. And how much will be the left amount? I can write this thing also. Left amount is how much? 15 minus 12. That will be 3. So I can say that 3 moles of H2 will be left. Till far is it clear, anyone? LR is clear to everyone that YN2 is the LR and 3 moles of H2 is left amount. This is clear to everyone. Very simple, very easy. And everything is logical. Tell me if it is clear. Yes, it is clear. Good. Now once you get the LR, our problem is solved. So we will be dealing with this stoichiometry here. Look at the screen. 1 mole and 2 moles of NH3. So what I will be dealing? Can I write it like 1 mole of N2 is giving me 2 moles of NH3? Because with the help of LR you have chosen that how you will be comparing with the product. So now I have how many moles are given? 4. So 4 moles of N2 will be giving me how many moles? 8 moles of NH3. That is the answer. Got it, everyone? Everyone is okay with the formation of ammonia? Or we are facing a lot of problem? Right? So you will try one question. Tetsu College, I hope you are getting it. This is your first class now, so I have to take care for you people. Let me know if any doubt is there, right? Just try this question, everyone. The given amount is 5 moles, and let's say 20 moles are given for this one. You have to, the question is already written. So you will be finding the moles. Find LR. Find the left amount. And then find the moles of NH3. All the things which we have calculated in the previous question, you have to find the same. Do it, everyone. I am waiting, and I have already written the balanced equation. Okay, so just if you want, you can take the help of the previous question. Do it. Tell me. Still finding any difficulty? Let me know. I'll explain. Okay. Oh, we are getting the answers. Very nice. LR is what? Nitrogen. 10 moles we are getting. Okay, this is nice. So can I write it like this, that obviously 1 mole, for 1 mole I need 3 moles of H2. I'm writing in short form, right? For ideally, for 5 moles I will be requiring 15 moles of H2. So, but I have 20. So this is in the excess. So excess reagent will be the H2, Lr will be the N2, and the left amount will be 5. 20 minus 15, that would be 5. And regarding the NH3 part, so 1 mole N2 is giving me 2 moles of NH3, right? And what is given? 5 moles of N2 will be giving me 10 moles of NH3. Clear to everyone? Clear, right? Easy na? This is easy, right? Let's do one more question. I hope this is okay with everyone. Tetsu College, I hope you are okay with this. Okay. Clear to everyone, right? Let's do one more question. Giving you the same one, okay? I'm not balancing it. You will write the balance equation again. Let's say this time I'm giving you 4 moles. And here I'm giving you, let's say, the 10 moles. Try this question, you have to find all of the same things. Find Lr, find left amount, and find the moles of NH3. Do it. Everyone, you got the answer. I got a lot of answers. LR is what? Hydrogen. Tetso College is saying nitrogen. Kohima is saying, Satna Center is saying hydrogen. Kohima, what is your answer? Tetso College, look at the screen, I'm telling you. I'm getting confused. A lot of answers are there. Everyone look at the screen. Let's balance it. 1 will be there, 3 will be there, 2 will be there. Okay. Now look at the screen, Tetso College. 1 mole of N2, it is reacting with 3 mole of H2, right? This is the standard. So ideally 4 mole of N2 should react with the 12 moles of H2, right? This time now I have just changed the values, right? So 4 moles of N2 ideally required 12 moles of hydrogen. But how much we have? Look at the screen now. We are having only 10. So I am already having lesser amount. Don't you think so? Earlier what was happening? 15 I have given, I guess, So that was in the excess amount. 4 moles ideally require 12 moles, right? 4 moles ideally require 12 moles. But here I have, like given in the question is 10, right? So this is already lesser. This is already lesser. So limiting reagent will be H2. Do you agree with me, Tetso College? Do you agree with me? Let me know, okay, if still any doubt is there. So LR is H2 and the excessive reagent is N2. Okay. So excessive reagent is N2. Then how to find out? First of all, we'll find the left amount later on. So first of all, we have found out the answer for LR, right? Now I have told you that once you get the LR, everything will be ruled by the LR only, right? So this is the LR here. Which one is the LR? My H2. Now, in order to find ammonia, let's find ammonia first. It's easier because, so I can say that 3 moles of H2 is giving me 2 moles of NH3. How much I have? I have the 10. So 10 moles. Now now there is no work of the 12 moles, okay? So 10 moles of H2 will give you how much amount of NH3? 2 by 3 into 10. That would be about 20 by 3. Nobody is getting 20 by 3. Check if this is correct. This is done. Everybody understood 20 by 3. Take your time and let me know, okay? Just write it down and let me know if you are okay with this. Tetso College, you are okay with this? Tetso College. Oh, you want a break? Okay, we'll take a break after this. Let's completely solve this question, okay? Then we'll take a break. I just forgot to give you the break. So now the left thing is you have to find the left amount. So what we have to do? First of all, according to the LR, we have to find out that how much amount of the H2 is required. Okay? So we will saying that 3 moles of L2, 3 moles of what we have, H2 is reacting with 1 mole of N2. Are you able to see that this time now I am making it again, I am first of all finding out that how much nitrogen is required, okay, according to the LR. So what is given in the question? 10 moles are given. So according to the 10 moles, how much is required? If 3 is requiring 1, so 10 will be requiring like this. So 10 by 3 moles of N2 is required. So what will be the left amount? Total was the 4, which is given in the question, minus 10 by 3. So if you check it, it would be 12 minus 10 by 3. It comes out to be 2 by 3. First of all, write it down. Let me know if you have any doubt. Clear? Tetsu College, any doubt? Tetsu College, feel free to write, okay? You got it? Then also write it down, and if you have doubt, then also write it down. If you don't have doubt, then also write down that, ma'am, we don't have any doubt. And Satna Center, GI is there. I hope it's clear to you also. Clear? Okay, then let's have a break. After the break, we'll start the next topic, okay? Meanwhile, let's have a break, then we'll start the next topic, yes. So we'll be having the break. Okay, so finally we are back after the break. I hope everyone is back after the break, right? So I hope you understood the concept of the LR. I'm giving you the few questions, one or two questions for the homework, and then we'll discuss the next thing, right? So everyone just write down the question. And this is the most common example of the ammonia, they will ask you. So I'm making here, and these three things you have to find out. So just write it down, everyone. So you will be finding in every question the LR, you have to find LR, you have to find ER, you have to find the left amount of whatever will be the LR, and you will be finding the moles of NH3, right? So these are the things which you have to find out, and these are the homework questions. Giving you one more. Okay, same questions and same things you have to find out. Clear to everyone? Right, just note it down and let me know once you are done. Then let's discuss the next thing. Okay, so I'm going to write the next topic here. We will be talking about some of the composition terms here. It's the percent compositions known as. So I'm also writing here the percent compositions. Very simple, very easy. So you people have seen, I guess, percent W by W. Okay, these are the general terms, like when you are talking about any of the chemical reaction, and if I want to tell you that students bring this much amount of NaOH solution, or students bring this much amount of sulfuric acid or anything, obviously I have to tell something. Like for the water we used to say bring the 5 liter, bring 10 liter. This is for the plain solutions we are talking, okay? But when we are having any solute solvent thing, any solution you are having, then you used to say it like I have a 40% NaOH solution. So what does that mean? Okay, so that 40% means that in the 100 grams of water I am having the 40 grams of NaOH. Are you getting me? So if I am saying that I have a 40% W by W NaOH solution. So NaOH solution is there, it means NaOH is the solute and water is the solvent, right? So it means that in the 100 grams of solvent, I have 40 grams of NaOH. Clear? So I am writing the few formulas here. If percent W by W, and many times mass by mass is also written. Now don't apply physics over here that mass and W weight are different. For the chemistry we are taking it same, okay? G value doesn't matter. So I am saying it will be like weight of solute divided by weight of solution, okay? So it's always solute by the solution into 100. Note it down. Then I have one more term with me which is known as percent W by V. This is weight of solute. Now V is there, so obviously we are talking about the volume. It's the volume of solution into 100. Clear, everyone? I have one more with me, and that is V by V. Volume of solute divided by volume of solution. When the solute and solvent both are in the liquid, then this will be the case. Just write it down, then let's do the questions. Tetsu College, you are there? Understood? You are understanding all of the things? Any doubt, Tetsu College, you have? Written, everyone? Okay, nice. Kohima Center, any doubt in these formulas? And the unit, take care of the unit. This is in grams, generally this is also in grams. This is in grams, this is in ml, generally. Okay, and obviously this would be in the ml and this would be in the ml. Okay, so do write for these units also. Okay, then do one question. Simple question, try it. Find percent W by W for 40 grams of NaOH. For 40 grams of NaOH in 1000 grams of solution. Quickly tell me the answer. These are the very, very easy questions. Okay, then I'll give you one more. What is the answer, everyone? Tetsu College, what is the answer? Tetsu College? Exactly. Kohima Center and Satna Center, you are correct. So you know that you are finding percent W by W. 40 is the weight of this is the solute, everyone. This is the solution is given. 40 divided by 1000 multiplied by 100. Directly you will be get 4% as the answer, right? Easy now? So easy this is. Try one more. For 20% NaOH solution, find out for 20% NaOH solution, find out, you can say that, find out the mass of solvent. Giving you a little tricky one, okay? Find out the mass of solvent if 40 grams of NaOH is present. Do it, tell me the answer. This time I have given you W by W, you know, and the weight of the solute is also given to you. You have to find the mass of the solvent. Okay, I got an answer from Satna Center. Kohima Center, what is your answer? Let me see. Now I don't have the answer, Satna Center, because these are the random questions I'm giving you. Okay, just framing the questions right now. So I'll solve it. Okay. See everyone. What is given this time? 20% is given this time. Why you are calculating the volume? Why you are writing 100 ml, 800 ml? I have asked you about the mass of the solute, na? So obviously it would be in the grams. Look at the screen, 20% given. This is the weight of what? Solute. 40 is there. And everyone, here we used to calculate the mass of solution. Don't get confused. In the question I've asked you for the solvent. But in the formula, we used to calculate for the solution. Okay, that is okay. So what will happen here? So, you know, you will be calculating the mass of solution first. That would be 40 into 100 by 20. So if you calculate it, that would be 200. Oh, which center is there? Satna Center. Jia, you have done a mistake. You have just given me the answer for the mass of solution, right? But you know that you have to find out the mass of solvent. So this is the mass of solution, which will be equal to the mass of the solute. We all know this thing, right? So that will be equal to the mass of solute plus mass of the solvent. So you have to add them both, right? Then you will be getting the mass of the solution. So I got 200 here. Mass of solute is 40 and the mass of solvent I want to find out. Right? So what will be the answer? Very good, Kohima Center, 160 grams. All of you are getting the answer, Kohima Center? All boys center, na? Clear? Tetso College clear to you? Satna Center, is it clear to you now? Any doubt you have? Okay, so these are the quite easy types of questions, but you should know them, right? Okay, let's do some more. Find out. Or let's say take the density as 2. That would be easy. This is the question in front of you, everyone. This time you have to find out the percent W by W and the percent W by V also for 80 grams of NaOH which is present in 800 grams of solution. I know that you people will very easily do the first part. For the second part you will be requiring the density, that is why I have given the density there. Try it, tell me the answer for both of them quickly. Okay, I got the answer for percent W by W. That is correct. Kohima Center, Tetsu College, give me the answer. Okay. Ria, you got the answer for percent W by V? Okay, I'll do it. Okay, let's check it. Kohima Center, I'm doing it. So what will happen over here? First of all, percent W by W is so simple. 80 grams is given, 1000 grams of solution is given, multiply by 100. Obviously, the answer would be 8%, right? So this is the 8% answer. Now, what will happen now? We have the percent W by V. So for this, I will be requiring the volume, right? So I will be requiring here now, what? I want the volume of solution here. Then I'll multiply it by 100 and I'll get my answer. Now I will be requiring the volume of solution. So what will happen over here, 1000 grams of solution is there. Everyone, see what will happen over here. Yes. What is the mistake, generally the people do? They used to write it like this. Density, I know that this is mass by volume. They will be putting 80 by V, that will equal to 2. This is absolutely wrong. Why? Because, do not put the mass of solute here. So that is why I am writing it in detail, and you should also write. V generally given in the question is density of solution. So if you are having the density of solution, you will be putting the mass of solution, and here you have to put the volume of solution. When I was in the 11th class and the first chapter was the mole, and I think I have told you this thing before also. I was so much confused that what is happening, I was really very confused, and I have studied this chapter after, 2-3 months, and I actually got to know that what is happening in the chapter. And then I really find it so easy that I was just getting the confused. So it's obvious because, in the junior classes, you haven't studied these things. So you have already getting the knowledge that so many things are getting, a lot of detail into itself, right? So it is okay to, have certain type of confusion. That is okay. But to keep this confusion forever is not okay, right? So if you are having the confusion, just solve it, okay? Try to ask the doubts, try to concern your peer group, because you know that we are in the live classes. I'm not physically present over there to, come to your seat and just check whether you are doing it correct or not, right? So just take the help. Don't feel shy or anything. If let's say you know that your, the partner in the class is doing the questions, but you are not able to solve it, ask for the help. And this is, I'm telling for those people, those who are able to solve the questions also. Try to help your friends over there in the mole concept, okay? So this will bring, this will help you to revise your own topic also, and this will help the other people also, right? So density is there, mass of solution is there, and volume of solution is there. So now the density is given as 2, mass of solution is given as 1000, I guess 1000 is given now, yeah. And the volume of solution we need to find. So it's done. That volume I got as 500 ml, right? Because density is gram per ml. So what will you do? Percent W by V. I'm putting it again. That was 80. Yeah, 80 by, right? 16% is the answer. Very good. Understood now everyone? Any doubt anyone? Any of the center if having any doubt? Then let me tell you one more interesting thing. Let us talk about, now you are able to do the percent V by V also, I know that, okay? So there is one more term which is known as mole fraction, right? So what is mole fraction? So let's say we know that we have a solute plus solvent, then they will make a solution, right? Then a solution will be formed. So like mole fraction is, let's say if you are calculating the mole fraction of solute, let's say if you are calculating. So generally it is denoted by capital X. So if let's say I'm calculating for the solute, it's a fraction. You know very well how to find out the fractions, right? That this much amount is present in the total of this much, right? So here it will be like the moles of solute divided by the moles, divided by the total moles. Either I can write total moles, or if I want I can write it like this also. Moles of solute plus moles of solvent. You are getting me? Similarly here, the moles of mole fraction for the solvent will be moles of solvent divided by total moles. So total will be solute plus solvent again. So do write this formula also. Clear everyone? And you know, sometimes this is also written. Now you people will tell me that how we can write this thing, the expression which I'm going to write now. If I want to find out the moles of solvent, mole fraction, 1 minus mole fraction of solute. How many of you understood it? Tell me, I'm waiting. The very last expression, everyone, you are understanding that? How can I write 1 minus x of solute? X is the mole fraction, right? Write down those who have understood it. Okay, Satna Center understood it. Kohima Center, you are getting it? Tetsu College. See, mole fraction we are talking now. So fraction is totally 1. So if let's say 0.3 is the mole fraction of a solute, what is the left amount? 1 minus 0.3, right? So if we subtract it from the 1, we will be getting the mole fraction for the other part, right? Because fraction will be from 0.1 to 0.9. That's it, right? Okay, you got it now, Kohima Center? This is the fraction, na? That is why we can subtract it from the 1. The total amount will be the 1. Okay, so if you subtract any one of the part, the left part will be the mole fraction of the other thing, right? Let us solve a question. You will better understand. Let us solve a question. Find out the mole fraction of O2 when present in a mixture of 64 grams of O2 and 8 grams of helium. Try this question, everyone. Two gases mixture is given. I have given you the masses also. You people are aware to find out the moles, how to find out the moles. Find out the moles and then with the help of the formula find out the mole fraction. Do it. You are getting it, Kohima Center, Tetsu College. What will be the answer? Who will tell me? I got the answer from Satna Center. See everyone, I am finding out first of all the moles of O2. This will be 64 divided by 32 because 32 is the mass. So I will be getting 2 moles of O2, right? Now I am going to find out the moles of the helium. This is 8. Given mass by molar mass I am doing, okay? So 8 will be divided by 4. 4 is the mass for helium. I am getting this also as a 2, right? Now, we have to find out the mole fraction of O2. What are the moles of O2? These are 2 divided by how much are the total moles? 2 plus 2. So I can write 2 by 4. Can I write it 1 by 2? So 1 by 2, it means 0.5 is the mole fraction. Right, everyone? Now, let's do by this particular thing. Let's say if I have to find out the mole fraction of helium also. What will be that? Again, because I'm getting the same moles, na? So 2 moles are there. Again 2 plus 2, again I'll be getting 2 by 4, so this will be again 0.5. And what I was saying that if I 1 minus 0.5 na, so I will be again getting the same amount, right? So this is the case. Just write it down everyone and tell me if you have any doubt. Take your time, write it down. Kohima Center, please let me know if you have any kind of confusion. Clear any doubt anyone? I'm waiting. Please let me know if there is any doubt. Okay, got it. Tetsu College, I hope you also got it. So I'm giving you the questions, right? I'm giving you the related 2 questions for the homework. Note it down. Find out the mole fraction for CH4 if 48 grams of CH4 is present with 48 grams of CH4 is present with, let's say, 64 grams of SO2. Okay? Giving you one more question. Equal masses of, this is a good question, CH4 and O2. Don't write O2. O2 and SO2 are present. Find mole fraction of both of them. Okay, this time I haven't given you the mass, but I have told you that equal masses are present. Okay, so I'm giving you the hint that you can assume any of the, variable for both of them. Let's say M is the mass, W is the mass. So these are the 2 questions. I'll be looking forward to see your answers in the WhatsApp group. Write down, tell me if you are done with this. Yes, we are done. You want me to give you more questions, Kohima Center? 6 is there in the clock, na? Should we do more? Okay, just tell me what chapter is going on in your school, Kohima Center and Satna Center. What chapters are going on in the school right now? You are done with the mole concept there? Okay. So what chapter they are following in the school? And Satna Center, you also let me know. Tetsu College, you can also tell me. Third chapter you are doing. Third chapter, it means which one? Periodic table. Okay, some are doing the chapter 8. Some are chapter 1. Okay, so you all are from the different schools. Now I got it. I remembered that. Okay, chapter 4. So basically everyone is covering the different chapters. Okay, don't worry. But you know, this is the very basic one. So we should know these things. Na? And okay, so you are doing the redox reactions. Okay. And when all of the centers will come, then definitely when we'll start with the atomic structure then. So this is the good thing that you have done the mole, the basic of the mole already. Okay. Yeah, I got it. The different schools are there. Okay. So I don't know what book your school is following. Or it's okay if you are having the NCERT, or I know that maybe in the Satna Center you are having the ICSE, or if you are following any state board, okay, that is okay, but keep on doing the questions, practicing the questions, similar kind of question as we have done in the class, similar kind of topic you can choose, because we are done with the mole, we are done with now the percent compositions also. You will find, yes, very good, Kohima Center, if you are following NCERT. In the NCERT, there are the questions related to these topics. You will see and check. Percent composition, I think that it is given over there. Okay. Now, 2-3 terms we haven't done it. I will cover it in the next class. Like the molarity, that we will discuss in the next class. Okay. So, I am just saying that go through the questions in the NCERT also. If you find any kind of difficulty, any doubt in the back exercises or anything, let me know. Post it in the group. I'll explain. Okay. And post your answers of the today's class questions also in your WhatsApp group, right? NCERT you are following, Satna Center. That is great. Because NCERT is very basic book, no? What happened many times the student rush for the, the complex books, and they forget about the basics. So we will not be doing that. NCERT is basic, and directly the questions will be there in the board exams also, and the questions in the, in the competition like the IT mains and the NEET also are from the NCERT, okay? So it's okay. It's good thing that if you are focusing on the NCERT, right? Okay. So that is it from my side today. If you have any kind of confusion or anything, post it in the group. Let me know, right? Okay then. Thank you so much. See you in the next class. Bye-bye.